Hello and welcome back to the channel. Today we're going to be considering an example based around a distillation column unit, and the objective of this unit is to separate species A from species B, and we can tell this from the fact that in our distillate D we have a 0.9 mole per mole fraction of A, and in our bottoms product B we have a 0.95 mole per mole fraction of our component B. So we're trying to separate A from B. And the objective here is we want to solve for our distillate flow rate and our bottoms flow rate, where in this example we've used units of moles per second. Pause the video here if you would like to try and complete the degree of freedom analysis for yourself as in the previous video, or keep watching to see how we approach an example like this. So again, we're going to make the assumption of steady state again. So at this stage we know that our material balance is simply going to reduce to in equals out. So the first equation, we have two unknowns. So from our degree of freedom analysis, we'll have yielded that we need to write two equations. Our first mass balance is going to be our total. So F equals B plus D. That's equation one. F coming in, D and B coming out. Our second equation is going to be the material balance on component A. And we have a 0.6 mole per mole fraction of A coming in, 0.9 mole per mole of A in the distillate, but in the bottoms product we're actually given the mole fraction for B. But recalling what we said in the last video, that means that our mole fraction in the bottom stream, component A, is, because there's only two components in our system, it's 1 minus this. So it's 0.05 mole per mole. So that means our second equation is 0.6 times 100, which is 60 units of moles per second, equals 0.9D plus 0.05 B. And that is our equation 2. And again, now we have a very simple case of where our F is 100, so we can replace that in here. Two equations with two unknowns, two material balances, total and for one of our components, and our two unknowns are the bottom and distillate flow rates. So solving like we did before, the easiest way is without a calculator to rearrange this one and substitute into here. So we'll get that 60 equals 0.9D plus 0.05. B is equal to 100 minus D. So therefore 60 is equal to 0.9D plus 5 minus 0.05D. Rearranging, subtract the 5, 55 is equal to 0.85D. So now, solving for D equal to 64.71 moles per second, which means that B, going back to our equation here, is 100 minus this, which is 35.29 mole per second. And that is exactly how you would solve a simple material balance around the distillation column. Thanks for watching, and I'll see you in the next one.